Hi, welcome in this session about cross-platform user interface development in Java with OpenJFX. So there are a couple of important terms that we're using in this title. So we are going to talk about user interfaces that are cross-platform so that you can create them once and execute them on a number of platforms. We're going to use Java, and the project that we will talk about is developed in the OpenJFX. 30 minutes is not a long session, so we are going to try to stick to the most essential parts that I want to explain. So we'll first of all talk about Java itself, JavaFX itself. What is JavaFX? Then an important part of the success of JavaFX is due to its ecosystem. So it's important that I spend a few minutes on the JavaFX ecosystem. We will also explain how the development of JavaFX is organized. How is it? How can one contribute, for example, and how do we guarantee that the quality is maintained, and so on. And finally, we will talk a bit about how the JavaFX APIs and implementations are structured and what architectural choices that have been made. We won't go into much detail as the allocated time does not allow for this, but hopefully I should be able to convince you that JavaFX is a modern user interface development platform that is very suitable for different kinds of devices, and that is very applicable if you're already a Java developer or if you want to join the Java development group. So first of all, what is JavaFX? It's not easy to give a definition, but I think the JavaFX platform contains the Java APIs that are used for client development in general and UI development in particular. So when I say it contains the Java APIs, I mean that these are really the APIs that are being developed in the OpenJDK umbrella. OpenJFX has its own project, the OpenJFX project, and the APIs that are being developed there are in the JavaFX namespace. So it's JavaFX Application, JavaFX Scene, and so on. Those are the packages that contain the JavaFX APIs and implementations. So while it is not a part of the core OpenJDK, it is part of the OpenJDK umbrella. Apart from being a part of the OpenJDK umbrella, it's important to notice that JavaFX is really a modern graphical toolkit, and it combines hardware acceleration with the typical advantages that we know in the Java world. For example, Java is well known for its security, maturity, backward compatibility, performant multi-threading, and there's a large ecosystem. So all the libraries or tools that you're using with Java can also be used to develop applications in JavaFX. For example, the IDEs, whether you're using NetBeans, IntelliJ, or Eclipse, they can also be used when you're developing JavaFX applications. So that is one of the major goals, to make it very easy for existing Java developers to also develop JavaFX applications. And this is actually about the only piece of code that I will show in this session. And this is mainly to convince you that JavaFX is really Java. So this is the very basic JavaFX application, including all the imports that we're using, and all the code that's required for the application to be executed. And this is, as you can see, this is really pure Java. So the JavaFX applications that you create directly or indirectly extend from the JavaFX application class. And if you override the start method, you're provided with a stage, which is a JavaFX root object that you can use to render a scene on. We use the regular Java APIs for getting system properties, where we get the properties, the Java version, the JavaFX version. Then a label is constructed, and that is a JavaFX control, so that's a JavaFX specific element already. And we assign some text to that label, and then we create a scene, a JavaFX scene. We create a stack pane, which is sort of a container that can contain other elements. In this case, we immediately assign the label to that stack pane, and we tell how large we want this scene to be. In this case, 640 pixels width and 480 pixels height. It's important to mention that JavaFX supports Retina and high DPI. So if your system has any of these displays, that will be taken care of by JavaFX internally. You don't have to add logic yourself for that. Then we assign the created scene to the stage that we were given, and we ask JavaFX to show that stage. And then you see the window on the top right of this slide. This is, of course, not a typical JavaFX application. This is really just the Hello World application. But it shows how easy it is for Java developers to use JavaFX. The more typical JavaFX applications are, for example, this is the Deep Space Trajectory Explorer created by AI Solutions for, it's being used by NASA. And this is really a very sophisticated piece of software where lots of computations and lots of rendering is done, and this really needs to be done with hardware accelerated platforms, and JavaFX is a perfect candidate for this. Also in medical software, like for example from Carl Zeiss, JavaFX is being used for doing the visualization. You can, of course, develop desktop applications with JavaFX, but it's important to realize that JavaFX also works on non-desktop or laptop devices. For example, on the Raspberry Pi, any embedded devices that are at least a bit powerful. For example, the Raspberry Pi 2 is more than powerful enough to run JavaFX applications. Or mobile applications like the DevOps conference scheduler that is shown here on the right, that runs on Android devices and iOS devices, and that is pure Java. So you create your application in Java, not in Objective-C or Swift or Android APIs. No, you just use Java, the very latest Java, and JavaFX, the very latest JavaFX. And what you then create can be rendered on desktop devices, laptops, embedded devices, mobile devices with 100% code reuse. Or you can create telematics applications, for example, for in-car navigation and infotainment. And because JavaFX is using the hardware acceleration provided by the platform, so we leverage the GPU whenever possible, it's really going at a very high performance. So that is, in a nutshell, what you can do with JavaFX and how it is linked to Java. As I mentioned in the beginning, JavaFX is one of the reasons for the popularity of JavaFX is its ecosystem. And if we look at the total stack of Java applications, JavaFX applications that are ultimately being rendered on hardware, we have JavaFX applications that are often using JavaFX libraries that are then built on top of the JavaFX platform, which is then delegating work to hardware specific drivers and so. We typically talk about the JavaFX platform, but on top of that is a whole ecosystem with software from individuals, organizations and companies that are extending the JavaFX platform. For example, Scenebuilder is a tool that's being distributed and maintained by GlueOn, and that is a very popular tool that allows you to create user interfaces in JavaFX with a drag and drop UI. So you simply drag the components and the controls that you want to be visualized in your application, and you set up the application in a visual way by doing this. And this interacts perfectly with IDEs, so that the logic behind the UI controls can be programmed in your IDE in Java and hooked with the elements that you created here. We provide that for Scenebuilder 15 and for the old 8.3 as well. Another very important and popular tool is ScenicView by Jonathan Giles, and this tool allows you to inspect the JavaFX properties of all the elements that you created at runtime. And this is really very useful in debugging if you think that, for example, this the space between the components in this vertical box is lower than I would expect. Then you can use this tool to see why things are the way they are. Because JavaFX uses CSS and has also APIs to set properties, it is often there might be different reasons why sizing or spacing and padding is different than what you might expect. It's all logic and following rules, but tools like ScenicView really help you to understand why things are this way. There are also a bunch of libraries that provide additional controls on top of JavaFX. So JavaFX comes with the typical controls like labels, buttons, image view, table view, list view, and so on. But very often in real-world applications you need more controls. And ControlsFX is an open source project by some volunteers who create additional controls that make them available to the wider JavaFX community. And if they are useful, they might even end up in the official JavaFX repository. More about that later, about how we evolve the JavaFX features. TaoXFX is another tool that's very popular, created by Gerrit Grunwald, and it contains a bunch of tiles, small widgets that can be used to render information somehow inside the JavaFX application. So the typical controls that you can see on this screen, you can create them from scratch as a developer, but it helps if there's already a framework that allows you to choose between a number of tiles. fxcl is a game engine that allows you to create games in Java or Kotlin, with JavaFX being the UI language. And fxcl will make sure that your top-level games are using the JavaFX APIs at a lower level. So this allows you to create very high-performant games using Java only, and then run them on the platform supported by JavaFX, being desktop, mobile, embedded. CalendarFX by Dirk Emmerman is one of the tools created by Dirk that gives more business-oriented applications already tools and controls that are ready to use and that are very often useful in specific business applications. The JavaFX ecosystem, while it is very wonderful, is something that should not be underestimated. And this is something that I think really should be mentioned on a conference like FOSDEM. The end applications, the JavaFX applications, are often created by employees of a company, or by consultants or consulting companies, and so. And very often, lots of money is paid for developing these applications. Now, these applications use then open source libraries or commercial libraries that are maintained by companies and individuals. And these libraries built on top of the OpenJFX platform. Now, developing the libraries, but also developing, maintaining, and distributing OpenJFX is not trivial, and therefore it is if we want to guarantee a high quality of OpenJFX, we really need to allocate enough resources to it. And while it is open source, we highly encourage companies to invest a bit in these open source roots of the ecosystem. And that is why we have the JavaFX long-term support program with GlueOn, which you can find at glueonhq.com/LTS, where you can be part of the development, influence the development, and get a guaranteed, secure, updated, mature version of JavaFX for a relative small fee, at least compared with how much the cost of a typical application is. There's a website that's being maintained by GlueOn, but we try to make it as open and as community driven as possible, which is OpenJFX.io, and that is actually really the start page of JavaFX. It contains very basic information on how to get started with JavaFX. It is open. So all the contents are on GitHub, so we do accept pull requests for this, keeping into account that we don't want drive-by contributions, and that is something that is important in the Java community in general. We're in for the long term. That means that if you want to improve something and you have a great idea, you should always think about how will this evolve in the next months, but also in the next 5-10 years. And that is what makes development, but also documentation, sometimes hard. So it takes time, and therefore we prefer to get a simple start point like OpenJFX.io, simple but relevant. Okay, so that was the ecosystem. We will now spend a few minutes on how the development of OpenJFX is being organized. There is often some confusion about JavaFX and OpenJFX, and I have to admit that it's very reasonable that there's confusion because the two names are used intermingled often. But my personal take on this is that JavaFX is the product name. It is maybe the marketing name. It is what developers can tell their management, we're working with JavaFX. And OpenJFX is the name of the project where JavaFX is being developed. It is a repository. It is, actually it's more than a repository. It's a platform where different people contribute via mailing list, repository, bug trackers, and so on. And it is part, as I said in the beginning, of the OpenJDK umbrella. So OpenJFX is one of the projects of OpenJDK. That might be a bit confusing because OpenJDK is both the project as well as the umbrella foundation that is overseeing the development in all the OpenJDK projects, including OpenJFX. There are lots of benefits in being an OpenJDK project. We can share the infrastructure, the experience, the rules, the issue tracker with OpenJDK itself. So OpenJDK and the Java platform in general is, with its more than 25 years of development, a very mature process, and lots of lessons have been learned over this long time. And JavaFX benefits from this because OpenJFX is part of the same family as the core Java SDK project. We also share the same roles that grant permissions to individuals to contribute to OpenJFX. So starting with the author, then going to committer, reviewer, or project lead. Those are the roles that are typical in every OpenJDK project, and we have them in OpenJFX as well. More on that later. The code is hosted on GitHub, and the license is the same as the OpenJDK license, which means GPL plus class path exception. So the code is on GitHub, and that is actually something that we started to do when JavaFX 11 was being created. We're currently at JavaFX 15.01, and recently with project Scara, the URL has changed to github.com/OpenJDK/JFX. So once again, here we are under the OpenJDK umbrella. Project Scara is a project that delivers a set of tools that make GitHub work better with the typical flow that was already in place for Java development. Java, again, with 25 plus years of development, has some specific requirements in development with respect to doing reviews, peer reviews, and making sure that there is no regression, keeping track of backport and so on, and making sure that the styles are checked. And the Scara tools make that much easier for developers so that they can't make mistakes too easily. The project leads of OpenJFX are Kevin Rushford from Oracle and myself from GlueOn. We keep track of issues in the Java bug system, which is a Java-based system that is hosted at bugs.openjdk.java.net. And it's a pretty powerful system, and it allows for lots of flexibility. And one of the major advantages of this is that everything that has ever been changed in the Java platform or in OpenJFX is being discussed, and every pull request that is being merged into the OpenJFX repository is linked to a JBS issue. As a consequence, if you want to understand why things are the way they are, you can simply look at when was this commit committed, or what pull request did it belong to, and then what JBS issue did it belong to. And then you will find in the discussion of that JBS issue, you will find the reasons on why things are changed. Typically a test case that failed before and that succeeded after. And this is really very important for large complex projects like OpenJFX or OpenJDK, of course. We had more than 20 new contributors via GitHub in the past years, and that is a major improvement because and that was actually our goal when we moved to GitHub previously. OpenJDK and also OpenJFX was hosted on an isolated repository in Mercurial hosted by Oracle, but it's now being developed in the open, and that made it easier to attract developers. The binaries, the SDK, for example, for JavaFX, the SDKs, but also the Maven artifacts and JMods, they are created by GlueOn. So we tag the repository and we build and distribute the binaries. We follow the same 6-month release cadence as Java has. So every 6 months a new major version is being released. And we deliver 3 types of builds. So the regular builds are, well, for example, JavaFX 15.01 is the latest to date. But more important, at least I personally think the next 2 are more important. The early access builds that we deliver are based on the head of the repository. 16 EA6 is something that we did last week, for example. And this is really a stable build, so this is not experimental. This is stable, or at least should be stable, and we highly recommend developers using those. And then we have the long-term support builds, 11.08, 11.09, 11.10. So all the important bug fixes and especially security fixes are backported to 11, and those are available to the GlueOnJFX 11 LTS customers who actually fund an important part of the development of OpenJFX. So, as I mentioned earlier, if you want new features to be part of OpenJFX, it's important that there's a commitment by the contributor. So not just hey, I think I have a cool new control, here it is, included. That's not going to work because that might slow down development on other parts. So therefore, it's typically being discussed on the mailing list, and Kevin and myself, being the OpenJFX project leads, will review the features, discuss them, and ultimately decide what's going to be in the platform or not. We'll do that in a very transparent way where the goals are very clear. We want to be consistent in the APIs, and that's a general goal in Java development, of course. We want them to be maintainable and to be supportable on a wide range of platforms. In the last minutes, I will spend a bit of time explaining how JavaFX is structured and how the architecture looks like. So reminding where we are in the stack, we are developing the JavaFX platform. And the JavaFX platform, if I have to explain it very briefly, I would divide it in 3 layers, although it's not really layered, but that's how you can think about it. At the top level, we have the JavaFX APIs. Those are the ones that are used by developers. So developers only code against the JavaFX APIs. Internally in JavaFX, these APIs are implemented, and well, lots of logic is written there. And at the lower level, the result of whatever the APIs are intended to do will result in changing the user interface. So, and there we are delegating the work to the low-level rendering components that are typically specific to operating systems. On macOS, for example, this is different than on Windows, and it is different than on Android or on Raspberry Pi with a touchscreen, for example. So the top level, which is the one that is interacted with by developers, contains the JavaFX APIs, which is a scene graph-based API. And in the example that we showed in the very beginning, you could see that we had a stage and a scene, and then a root node, which was a container, a stack pane, I believe, which contained other nodes. So, and that is the scene graph that JavaFX maintains internally. So developers, they declare the state of this scene graph, and they declare the animations and so. But JavaFX works in a retained mode. So the developer just tells what he wants to do, and then JavaFX will make sure that it's being rendered. And the rendering pipeline is different from the thread that is responding to user interface changes and so on. So the rendering pipeline, which can be very OS specific, deals with the rendering. And that is isolated from the code invoked by the developer. And this is one of the key enablers for cross-platform development, because this top-level API, scene graph based, does not depend on the way that things are actually rendered at a lower level. So the JavaFX rendering is trying to use hardware acceleration where possible, and as I said, because it's separated from the top-level API, we can have platform-dependent optimizations where possible. And there's also a software rendering pipeline that can be used when hardware rendering is not available. So there are pipelines for desktop, mobile, and embedded systems. Finally, some words about some future directions that we are taking with JavaFX. We see that there's an increased interest in native applications, and for very understanding reasons, because for optimal performance, it is often better to use native code instead of having a JVM at the target machine. But this requires that we can create native applications using Java. It's actually a requirement for iOS. On iOS, it's not allowed to have a JVM compiling codes on the fly, for example. So in Java, we need to somehow go from Java bytecode to native code. And that is what the GraalVM native image fairly recent project in the Oracle Labs is allowing us to do. So GraalVM translates your Java bytecode into native code. That's not enough. We also need to have the native code that's part of the Java and JavaFX to be compiled for the specific target. And then everything needs to be combined and linked at build time so that it can work at runtime. And so that's a whole tool chain that's needed. And that is what GlueOnSubstrate is doing. So GlueOnSubstrate is converting your Java application, your JavaFX application, into native executables for desktop, mobile, or embedded, and it will pull in all the required dependencies. This is an open source project, and you typically invoke that with an IDE plugin, and you can also use GitHub Actions to then create native applications and upload them to, for example, the App Store or the Play Store. There are examples on the internet. Documentation is something that always can be approved and should be approved, but this is, I believe, the client development of the future. You can use Java, your regular existing tools, and you create targeted applications for different systems, but your code does not depend on those low-level details of the operating system or the distribution guidelines of those systems. So in summary, JavaFX provides a user interface for Java. It is Java and it leverages all of its benefits. It allows Java developers to create user applications using Java only and deploy them to desktop, mobile, and embedded. There's a huge ecosystem that you can benefit from, and it is developed in an open development model. And with this, I think it's time for questions.